Hello and welcome to my channel. I am Esa. Please, if you are new here, kindly subscribe to my channel. And if you have been watching my videos and you not yet subscribed, please kindly subscribe for us to build the mathematics community. In this lesson, we'll be looking at conic section, and under the conic section, we'll be looking at our parabola. And within the parabola, we are going to look at how to find the standard form of the equation of a parabola given the focus and the directrix. We will take 1, 2, 3, 4. We will take 4 questions to improve our understanding. And all the 4 questions that we are going to take, the parabola has its vectors at the origin. Okay. Then, whenever I write a question, I'll prompt you why. Now, the first one is that find the standard form of the equation of the find the standard form of the equation of a parabola with focus at 7,0 and directrix x equal to -7 and directrix x equal to -7. Now, whenever we get this one, what do we do? What we are going to do is that let's write the standard form of the equation of the parabola y equal to 4ax, and then we also have x squared equal to 4ay. In other books, here will be p, here will be p. There's no problem. I'm using a. Now, how do we determine that this one requires the use of this equation or it requires the use of that equation? Now, what we are going to use is that we will use the focus to determine. So let's come to the focus. If we look at the focus, you see that we have 7, 0. So the 7, 0 is telling us that if x is 7, then y coordinate is 0. This means that this parabola has its axis of symmetry on the x-axis, and on the x-axis 7 is positive, so 7 is on the positive x-axis, and it's like something like this one, 7,0, because the vectors is here. Because the focus, you take the first one as the distance between the vectors to the focus. So if this is 7, then it means that it is on the x-axis. Very simple as that. So here we know that this is what we have. Now, this 7 represents the distance between the vectors and the focus, and it is what we call the A. If you have been following my videos. So here we have A to be equal to 7. So now we are good to go. So we write y squared equal to 4 times 7x, and then we have y squared equal to 28x as the equation of a parabola with its focus at 7,0 and directrix equal to -7. So the directrix will be here. Very simple as that. Let's take the next example. The next example is this one. We have f of -9. Sorry, we have f of 0, -9, and the directrix is y, -9, and the directrix here, oh, that is not how it is. You have -9, 0, and the directrix is x equal to +9. Yes, that's what I have there. So I said that you look at the focus. So here, if you check the focus here, we have the distance between the vectors to the focus to be -9. and this is what we have there on the x-axis. So this one is on the negative x-axis, but you can still use this standard form. So you write y squared equal to 4ax with our a equal to negative 9. So we have y squared equal to 4 into bracket negative 9x, and this will give us y squared equal to minus 36x as the standard form of the equation of a parabola with its focus at negative 9, 0 and directed as positive 9. So this one, they are not difficult, they are just tricky, that you have to always consider the focus. So use the focus to determine. Okay, now let's look at this one. Let's look at this one. What about this? What is the equation? Okay, let me look inside this book and then pick one question from here. Yes, we have the focus. What is the equation of the parabola with the focus? The focus is 0 minus 15, and the directrix is, so the focus is 0 minus 15, and the directrix is y equal to positive 15. So how do we do this one? So here, since we have 0, then it means on the x-axis we have 0, on the y-axis we have negative 15. So this shows that the parabola has its axis of symmetry on the y-axis. And on the y-axis we have negative 15. So it is on the negative, the focus is on the negative y-axis. So here we write x squared equal to 4ay. Very simple as that. And here, what is the a? The a is the minus 15. So we take x squared equal to 4 into minus 15y, and we have x squared equal to minus 60y. This is the standard form of the equation of a parabola centered at the origin and focus on the positive x-axis with the positive y-axis with the y-axis as its axis of symmetry. It is not centered but vectors. Correct. I've always been using center instead of saying vectors. So this is the standard form of the equation of a parabola with its vectors at 0, 0, that's the origin, and the y-axis as the axis of symmetry, and the focus is on the positive y-axis. But this answer that we have had here is a parabola with its vectors at the origin and the y-axis as its axis of symmetry, but this parabola will open downwards because of the negative sign. So the focus is on the negative y-axis. Very, very simple as that. So you should take note of that. Now let's look at the last one. The last one, I'm going to look at the focus to be 0, positive 9, and the directrix to be y equal to negative 9. Now, since here is 0, then it means that the vectors is at the origin, and 9 is on the y-axis. Since 9 is positive, then the focus is on the positive y-axis. So we take x squared is equal to 4ay, and here we have a to be positive 9. So we have 4 times positive 9 times y equal to x squared, and that will give us x squared equal to positive 36y as the equation of the parabola with its focus at 0, positive 9, and directrix as negative 9. So always, when you are giving this, just check the focus. The focus will give you the A, because we are saying that this value is the distance between the vertex and the focus. The distance between the vertex and the focus. In the same way, this value too is the distance between the vertex and the focus. But we look at this one. Where the focus is where the parabola tends to. It is not where the directrix is. That is why we have not been using the directrix. The parabola will always go to where the focus is. Thank you for watching. Please kindly subscribe, like, share, and leave your comments. Bye bye.